Let's talk about exponential and logarithmic functions. This is just a little bit of algebra. What are exponential and logarithmic functions? Well, the famous exponential function, in fact, it is always capitalized and called the exponential function, is this one. It is y equals e to the x. Now, e is a number that is approximately 2.71828, etc., and it's named after a guy, or the e comes from a guy. His name was Leonard Euler. It's pronounced Euler, but spelled with an e, so that's how he is infamous. The log function, okay, I probably should capitalize it actually. The log function is y equals the natural log of x, which is the same thing as the log base e of x. So it's based on that too. Now, there are some, this is called natural log. There are some other log functions and exponentials. You've got things like y equals 10 to the x, and then you could have log of x. And this one, this is called a common log. Base 10 is what it's considered. It is log base 10 of x. So if I make it into a function, which I had not done, let me do that. That is called a common log. Calculators tend to have these two as buttons on them. Newer TI-83s and 84s have log base anything, kind of in the depths of the math part of the calculator, but these two are on the actual buttons, so you will see those fairly often. Now let's look at some of the properties of logs, because those are some things that you have done in college algebra or wherever you studied the equivalent of that, and these are important in terms of trying to do calculus and working some things out. So, properties of logs. I'm going to use m and n as values. So I'm going to say this. I'm going to say that I want the log, and I'm going to go ahead and make this kind of generic. So the log base b. b is considered the base. First of all, I'm going to give you a definition. This is not just a property. This is a definition that is something that you will need. So log base b of, and let me just put x and y here, okay, means the same thing as b to the y equals x. Notice the relationship. The base raised to the answer is equal to the stuff inside. So that's a big deal. Now, not only is that a definition, but it goes forwards and backwards. So if I've got this, I can write it like this, or if I've got this, I can write it like this. That's a big deal. That is the way that you turn logs and exponentials into each other. So before we do properties, I'm going to make sure that you see that. Now, the actual properties, let me put those down here. There are three main ones. The first one is, what if you've got the log base b of some kind of a multiplication problem, m multiplied by n? Well, because logs represent exponents, then what happens is when you multiply exponents, or multiply numbers with exponents, you add the exponents. So the result is that this is the log base b of m plus the log base b of n. Now what that does is it simplifies oftentimes, so that should help. The second major one is, what if you've got division? Log base b of m divided by n. Well, that is the log base b of m subtract log base b of n. So when you divide numbers with exponents, you subtract their exponents. That relates there. The third biggie is this one. Log base b of m to the x power. Well, that is equal to x log base b of m. Now, that is not a derivative. It's just a property of logarithms. So think about raising a number that has an exponent to an exponent. What happens is you multiply the exponents. Well, here's one exponent and here's the other one. Log represents an exponent. So those are the big three log properties. Now some smaller ones that you probably will recognize, probably have in your knowledge bank, but what if you've got log base b of b? Well, if this and this match, the answer is 1. If you've got log base b of 1, then this one is 0. So, and just to kind of follow that pattern along, this one, if I've got b to the x, then this one is x. So b to the x equals b to the x. The logarithm function is 1-to-1, so it can go backwards and forwards very easily with no loss of good information. Let's look at a couple of examples for log properties. Let's take the log base b of 3x squared, and let's expand that as far as we can. This is just an algebra exercise. So if we do that, the first thing we might do is take the 2 and put it in front. So this is the log base b of 3x. So we've got this equals 2 times, now I've got to block that off because it's the 2 times the whole thing, but log base b of 3 plus log base b of x. So that's expanded out. Let me take one that I need to condense. So let's condense this one. It's got log base b of 3 minus log base b of 5 plus 2 times the log base b of 7. Let's condense that one. So if I work at this, these all have the same base. That has to happen. But if I take these two together first, then subtraction of logs means division. So that gives me log base b of 3/5. And then I've got to add the log base b of 7, 2 of them. 2 log base b of 7, I need to put that 2 up here. So that is log base b of 3/5 plus the log base b of 7 squared, or 49. So now I've got addition of logs. So this is the log of base b of 49 times 3/5. And you could do whatever you want with that. But anyway, that's just a little bit of an example of using those. You're probably pretty comfortable with those from algebra. We don't use them with numbers all that much in calculus, but I just had numbers here for now.